The next part is using step functions. And a step function looks like a little ladder. So you can see it looks like a little ladder. And so the definition for a step function is that step functions resemble stair steps. One common type of step function is the greatest integer function. And the symbol that is used is this one here. It looks like two little brackets. And we define it as the greatest integer less than or equal to x. So here, we want to evaluate the greatest integer. So the best thing to do here is remember what the definition is. Less than or equal to x. So I'm going to underline this part because this is going to be the most important part. And I'm also going to draw a number line to help us understand what this statement means. Okay, so if we're looking at f of x is -1, and if I plug it in here for x, then when we bring this out, the definition says that it's going to be the greatest integer less than or equal to x. Since -1 is an integer, then this is just going to come out as -1. My y would be -1. So this is just going to be -1. If we plug in -1/2, then -1/2 is not an integer. So -1/2 is located right here. Okay, and this is not an integer. And so by definition, we need to get the integer that is less than x. So the integer less than x would be this one here. So this is the integer less than 1/2, the greatest integer less than 1/2. So for -1/2, this is going to come out to -1. So another example, 1/10 would be somewhere in here. This is 1/10. Okay, so 1/10 is not an integer. So the greatest integer and keywords less than 1/10 would be 0. So we go to the left. So the first greatest integer less than 1/10 is 0, since that's the first one to the left. So that would be a 0. 1.5 is right here. Since 1.5 is a decimal, that means that that's not an integer. And so the greatest integer less than 1.5 would be the first one we see to the left, which is 1. And then 1.9 is right here. And again, 1.9 is not an integer since it's a decimal. So 1.9, the greatest integer less than that is to the left, which again would be 1. So when you graph these, we go from -1, gives us a -1, which is here. -1/2 gives us -1. And if we keep going, we would get to 0. And at 0, let me plug in 0 here. So 0 is right here. The greatest integer less than or equal to that is going to be 0. So at 0, we get 0. So we put a closed dot, but notice here it has an open dot because there's so many numbers in here that are going to be close to 0, but not quite at 0. So for example, negative 0.1. Well, negative 0.1, the greatest integer less than that would be negative 1. That's why it would be here. And then we have at 1/10, we have 0. At 1.5, we have 1. But at 2, notice what happens at 2. For 2, this comes out as a 2. So at 2, we have to go up to 2. So we use an open circle here because at 2, it's not 1. Instead, it's a 2. So we need to finish it by putting an open circle to include all these numbers close to that value. So let's try another one. Evaluate the function when x is equal to negative 1, 2, and 3/2. So again, if it helps, draw yourself a number line. So my function is f of x is equal to the absolute step function here, x, the greatest integer, plus 1. And we want to know when f is negative 1, what we're going to get. So we have negative 1 plus 1. Well, negative 1 is right here, and you can see that it is already equal to the greatest integer. So that comes out as negative 1 plus 1, which is 0. So I'm going to make a little table here and just plug in when x is negative 1, we get y equals 0. For f of 2, I'm going to get, plug that in here. So f of 2 is over here, and that's already the greatest integer. So that's going to come out as 2 plus 1 will give me 3. And then the last one, f of 3/2. So that 3/2 is 1.5, which is right here. And so that is not an integer. So the greatest integer less than that would be the 1. So this 3/2 comes out as a 1. So we get 2. Okay, so that's how we would evaluate this function. So now we want to sketch it. So to sketch, we need some numbers. So I'm going to just choose a few here, negative 2, negative 1, 0, 1, and 2. So if I plug in negative 2, we get 1/2 times negative 2. And I'm going to go ahead and use a number line again, just so that we can see the numbers. So negative 2 is going to give me 1/2 times negative 2 is negative 1. So that comes out to negative 1. Since negative 1 is already an integer. F of negative 1 would give us 1/2 times negative 1. One-half times negative 1 is negative 1/2. So negative 1/2 is right here. And that's not an integer, so the greatest integer less than negative 1/2 would be negative 1. So we get negative 1. F of 0, 1/2 times 0. So 0 is an integer, so that just comes out as 0. And then f of 1, 1/2 times 1 gives me 1/2. So half is right here. So the greatest integer less than a half is going to be 1. And then last, f of 2, I'll put it on this side. F of 1 is already an integer, so that comes out as 1. For this problem, for f of 1, we get 1/2 times 1, which is 1/2. And 1/2 is right here. So the greatest smallest integer would be 0. So for the 1, we get 0. If we plug in 2, right here, 1/2 times 2 gives us 1. That's already an integer, so my answer is going to be 1. And then for 3, if I plug in 1/2 times 3, I get 3/2. That's 1.5, so that's going to come out as 1. And then for f of 4, we would get 1/2 times 4 is 2. 2 is already an integer. And then 5 times 1/2 is 5/2, which is 2.5. So the greatest smallest integer would also be 2. So if we want to plot this, we have -2 and -1. It's right here, -1 and 1. 0, 0 is right here. And then we have 1 and 0, which is right here. Then we have 2 and 1, which is right here. And then we have 3 and 1. So you can see your little staircase building up. And then we have 4 and 2. And 5 and 2. Yep, so we graphed our points. Now we need to fill in these gaps. So if I was to choose anything between this point and this point, since they're not integers, it's always going to end up being -1. So I'm going to draw my line here. But at 0, we got 0, so this has to be an open circle. And so here I have that at 2, I get 1. So in here, for 2, I'm going to have an open circle. This should be open circle. And then for 3 here, I'm going to have a closed circle. An open circle for my next one. And then this is going to keep going. Then we would have an open circle and so on. Okay, so this here is an open circle. And so that would be how we graph a step function.